Scientists claim that the universe began with an event known as the Big Bang, which took place about 13.7 billion years ago. But the question remains, how and why did that explosion occur? Did it develop over time? We investigated the science and history of our universe, and the Big Bang theory has stood as the primary explanation for the phenomena we've observed. Numerous studies and scientists have worked on research collection, and the collected data consistently supports the Big Bang theory as the principal explanation for how the universe came into existence. According to this theory, a type of energy known as dark energy, even more prevalent than galactic energy, is seen as the anti-gravitational force that has been the universe's driving force of expansion since the beginning of time. Today's science is vastly different from what it was like in the past. With new theories and advancing technology, we frequently discover that what we previously believed to be accurate is no longer the case. Makaku has even proposed the formal debunking of the Big Bang theory, partly because the James Webb Space Telescope has discovered 750 brand new galaxies that look completely different from what scientists had expected. This discovery presents a fresh perspective, encouraging us to investigate how the James Webb Telescope is reshaping our knowledge of the entire universe. Come along with us on this thrilling journey beyond the visible universe, and let's investigate the brand new galaxies discovered. For more information and to stay updated with the most recent universe-related news, follow our channel. Like this video, share it to reach a larger audience, and turn on notifications for new updates. The images of the brand new galaxies discovered by the James Webb Telescope are simply breathtaking. In just one picture, we can observe hundreds of galaxies. The magnificence and splendor of these photographs are truly remarkable. Yet, what's astonishing to researchers is quite different from what might surprise the average person. While these images are motivating to many, they don't align with the expectations of the scientific community. Based on current theories, the number of observed galaxies is much larger than anticipated. These galaxies are unlike others in that they are smaller than expected and exhibit ages far more advanced than predicted. These surprises are sparking a sense of alarm among scientists, with even an article beginning with the word panic in its title, underscoring the gravity of the situation. These galaxies defy what was long anticipated by long-standing theories. Scientists have long suggested that the Big Bang theory be the principal explanation for how our vast universe came to be. According to this theory, around 13.7 billion years ago, the universe originated from a mysterious cosmic event. However, the newly captured images challenge the long-accepted story of how the universe was created. Images from the James Webb Telescope are shaking our understanding of the universe's origins, particularly since they appear to conflict with the Big Bang theory, which has been regarded as an unquestionable fact by most cosmologists. The galaxies seen in these images are surprisingly small, smooth, ancient, and far more abundant than predictions based on the Big Bang theory. Many of these galaxies are 2 to 3 times smaller than those captured by the Hubble Space Telescope, which completely contradicts the expectations set by the expanding universe hypothesis. According to this theory, as the universe expands, objects should appear larger with increased distance. However, the galaxies observed by James Webb appear to contradict that idea. Furthermore, the smoothness of these galaxies was not anticipated. According to the Big Bang theory, galaxies should display irregularities and structural variations due to the dynamics of their formation and evolution. However, the images show galaxies that are remarkably smooth, structures without the necessary roughness and complexity that would typically be expected for galaxies of their age. This challenges the anticipated timeline for the formation and imagined evolution of galaxies in relation to the Big Bang theory as a whole. In the beginning, all matter, energy, and the early universe, the foundational elements of the cosmos, were compressed into an extremely dense point known as the singularity. At this moment, the density reached an infinitely high value due to the extreme compression of matter and energy. The concept of the singularity is rooted in our comprehension of physics, particularly in Albert Einstein's general theory of relativity. Within this singularity, all the matter and energy of the universe existed in a highly concentrated form. The incredible density suggests that an immense amount of mass and energy was compressed into an infinitesimally small space under immense pressure and density. In such extreme conditions, the temperature inside the singularity would be beyond anything imaginable or measurable by today's standards. Within this hot, dense point was the original source of everything we know about the universe. The singularity marked the start of the cosmos, from which everything emerged. After the singularity, the universe began its inflationary and expansionary period, which took place over roughly 13.7 billion years, eventually leading to the universe as we observe it now. The expansion of the universe started with a rapid, enormous burst known as cosmic inflation. During this phase, the universe grew much more quickly than the speed of light, extending into space itself and pulling everything along with it. Cosmic inflation was a major factor in forming the large-scale structure of the universe, smoothing out irregularities, equalizing the distribution of matter and energy, and setting the stage for subsequent star formation in galaxies and other cosmic structures. As the universe continued to expand, the rate of its expansion gradually slowed. It is important to note that while cosmic inflation was a brief period of rapid expansion, the universe has continued expanding at a measurable rate, a process known as cosmic expansion. Scientists have studied evidence of this expansion, including the redshift of light from distant galaxies. Redshift occurs when light waves become more elongated as they move toward the red end of the spectrum during the universe's growth. During the expansion, all the matter that makes up the universe was compressed into an extremely small volume. It became apparent that matter could not survive in such a compressed state, so transformations took place as the universe expanded and cooled. In this early phase, particles like protons, neutrons, and electrons began interacting. These interactions, along with energy and light, played a crucial role in the formation of matter in the universe during the first minutes following the Big Bang. As the universe cooled further, atomic nuclei began to form in a process called nucleosynthesis. This phase occurred within the first few minutes after the Big Bang. During this time, the simplest and lightest elements, hydrogen, helium, and small traces of lithium, were created. These primordial elements would later serve as the building blocks for stars and galaxies. Over the next few 100,000 years, the universe continued to expand and cool. Eventually, it reached a point where electrons could combine with atomic nuclei to form neutral atoms, a process known as recombination. This allowed light to travel freely for the first time, resulting in what we now observe as the cosmic microwave background, CMB, a faint glow left over from the early universe, and one of the strongest pieces of evidence supporting the Big Bang theory. The formation of the first stars and galaxies came later, during a period known as the Cosmic Dark Ages, which ended with the epoch of reionization. During this time, the first sources of light, early stars, quasars, and galaxies, began to ionize the hydrogen gas around them, bringing light back to the universe and shaping its structure as we see it today. However, modern observations, particularly from the James Webb Space Telescope, are revealing anomalies that challenge this established timeline. The discovery of galaxies that appear to be fully formed, ancient, and well-structured, despite existing when the universe was supposedly very young, raises questions about whether the universe could have evolved so quickly under the Big Bang model. If galaxies formed faster and earlier than expected, then cosmologists may need to revise key assumptions about the early universe. Some theories suggest the possibility of an alternative cosmic origin, or that our understanding of dark matter, dark energy, or gravity itself may need refinement. Further complicating the matter is the discovery of gravitational anomalies and unexplained phenomena, such as the distribution of matter in galactic filaments and vast cosmic voids. These observations don't always align with the uniform expansion predicted by standard models. Despite these challenges, the Big Bang theory remains the dominant explanation for the origin of the universe, backed by decades of observations, simulations, and theoretical work. Yet science thrives on questioning, re-evaluation, and revision. As we continue exploring the depths of space, with tools like the James Webb Space Telescope and future missions like Nancy Grace Roman Space Telescope and Euclid, we may be on the brink of a paradigm shift. These technologies will enable us to peer further into the universe's past, potentially offering insights that could support, reshape, or even overturn existing theories. The universe is vast, complex, and mysterious. Each new image, discovery, and data point adds a piece to the cosmic puzzle. Whether the Big Bang was truly the beginning, or simply one chapter in a much larger cosmic story, remains to be seen. Called nucleosynthesis, it involved the chaotic formation of basic components, and disrupted galaxies formed by multiple collisions were expected to be observed. But the James Webb images present a different narrative. Instead of chaotic, colliding galaxies, the telescope captures well-organized disk-like and spiral-shaped galaxies, similar to the ones that are present in the universe today. This unexpected finding challenges the assumption that mergers are an essential component of galaxy evolution. These galaxies have not undergone many, or any, mergers. it becomes unlikely that small galaxies would grow into massive structures, as originally predicted. This suggests that these galaxies might have consistently been larger than anticipated. Additionally, the optical illusion predicted by the expanding universe theory, where objects appear smaller due to cosmic expansion, does not hold true in this case. Thus, many of the concepts we previously held to be true may no longer be accurate. The age and abundance of galaxies that the James Webb Telescope has revealed also cast doubt on the validity of the Big Bang theory. The James Webb Telescope is equipped with filters that allow it to capture images in the infrared spectrum, making it possible for astronomers to investigate the hues of distant galaxies. By studying these colors, scientists can calculate the age of stars and galaxies. If you enjoyed this video, please like it, share it with others, and subscribe to the channel to stay informed about our future videos. The results of the James Webb Space Telescope signify a significant leap forward in our understanding of the universe. Its ability to observe distant galaxies with unprecedented clarity allows scientists to gather data that challenges existing cosmic models. The JWST's sensitivity to infrared light has allowed it to peer deeper into the universe than ever before, revealing objects that were previously beyond reach. These discoveries are reshaping our understanding of the universe's early stages and forcing a re-evaluation of established theories like the Big Bang. One of the key implications of these findings is the possibility that our understanding of galaxy formation and the early universe might need to be rethought. The conventional idea of chaotic, irregular galaxies that originated from mergers and collisions may not be as accurate as once believed. Many of the structures captured by the JWST are smooth and organized, suggesting that the process of galaxy formation could have been much more systematic than previously imagined. This raises new questions regarding the mechanisms that drive the formation and evolution of galaxies in the early universe. The apparent age of these discoveries is fascinating. The JWST observations suggest that some of these galaxies are much older than anticipated, contradicting the Big Bang model's predictions. According to the Big Bang theory, galaxies and stars should have formed gradually over billions of years and matured over time. However, the images from the JWST suggest that these galaxies could be much older than expected, which impedes our comprehension of the universe's timeline. If these galaxies really are that old, according to the data, it could indicate that a lot of galaxies were formed earlier in the universe's history than anticipated. The presence of such old and well-formed galaxies so early in the history of the universe is a major puzzle. It forces scientists to reconsider the processes that allowed for such rapid galaxy formation. The standard model of the universe's evolution holds that galaxies formed gradually over billions of years. But the findings of JWST appear to indicate that some galaxies formed much more quickly than anticipated. This has significant ramifications for our comprehension of how the universe evolved and the role that dark cosmic forces and energy may have played in shaping it. The unexpected discoveries made by the James Webb Telescope are not only reshaping our understanding of the universe's past, but also opening up new possibilities for future research. As scientists continue analyzing the data, they will likely uncover even more surprising details about the origins and evolution of the universe. These findings suggest that the universe is far more complex and dynamic than we ever imagined, highlighting the need for new models and theories to help explain the vast array of emerging phenomena. As technology continues to advance, new telescopes and instruments will offer even deeper insights into the mysteries of the universe. The JWST is just the beginning of a new era in space exploration, and its discoveries will undoubtedly lead to numerous additional advances in our understanding of the cosmos. The future of cosmology is full of exciting possibilities, and ongoing research will likely provide answers to some of the most profound questions about the universe's origins and its ultimate fate. In conclusion, the James Webb Space Telescope has already begun to challenge some of the most fundamental ideas about the universe. New discoveries of galaxies that defy the laws of physics and the Big Bang theory are forcing scientists to rethink everything they thought they knew about the cosmos. These findings are pushing the boundaries of our knowledge and opening up brand new perspectives. As we continue to examine the JWST data and prepare for future missions, even more shocking revelations regarding the universe and its beginnings are sure to emerge. The journey of discovery is just getting started. Answers to the most fundamental questions and mysteries may be closer than we think. The discoveries made by the James Webb Space Telescope have begun a brand new chapter in the study of the cosmos. The level of detail in its images and data is extraordinary, revealing previously unseen aspects of the universe that challenge long-standing theories. According to these revelations, the universe may have a more complex and multifaceted history than we have understood up until now. The JWST's capabilities allow it to dig deeper into time and space, unlocking the potential to answer some of the most profound questions in cosmology. One of the most significant aspects of these discoveries is the way in which they complicate the Big Bang theory. For decades, this model was considered to be the most trustworthy explanation for the origin of the universe. Yet, the recent findings of galaxies that are smaller and smoother than anticipated raise serious doubts about its accuracy. The fact that the JWST has uncovered galaxies that appear to be far more mature than expected suggests that the processes that led to their formation might have occurred in a different way than previously assumed. This directly contradicts the notion that galaxies formed gradually over billions of years through acquisitions and collisions.